we're creating a bunch of new courses at Nova Datacom, and one of the questions that I get quite a bit is, okay, how exactly did you pull that off as far as the recording and everything else? So I wanted to open the kimono a little bit and share with you about how the details of how I do some of that. I have a Macintosh that I use as my primary operating system, and I'm running Parallels, which is a virtual environment that can run Windows 7. So I run Windows 7 inside of Parallels inside my Mac, and that's how it operates. I also have Linux, a couple of flavors that I run inside the Macintosh as well, also on Parallels. Then inside of Windows 7, I run GNS3. Now, why would I run that 3 levels deep? Is because I really want to have the ability to do packet captures and all the other cool details that allows me to do. So one of the questions that I thought I would answer for a lot of people is, how exactly do you set up GNS to make it really work for you? First of all, it won't work well for switches, so throw that out. But it does work great as far as practicing iOS and routing. So this topology right here is the new topology that we're going to be using for the new IC&D class. We also have a bunch of new Network Plus, Security Plus, and others. But let me walk you through step by step how I get all of this working inside of GNS3 and how I use it to teach effective classes. Thanks for joining me. Hey everybody, I'm putting together the final details on a brand new release, if you will, of IC&D 1 through Nova Datacom, and one of the questions I get all the time is, how do I practice this? If I don't have real gear, how do I practice it? And one of the really simple ways of doing that is to use a tool called GNS3. It's great for the routers, not so much for the switching practice, but for the routing, it's terrific. So let me walk through the steps of exactly how to do that. Here's the topology that we'll be using in this new class. It's also similar to the framework I use for Network Plus and Security Plus and IC&D2 as well. So this will serve a lot of purposes. So one thing I want to do is I want to integrate my own PC into GNS3. And how do I do that? Well, I take my Windows 7 machine and I simply add a new msloopback interface. It's a virtual interface. I have a YouTube video on that in one of my other offerings. If you want to take a look at that, it's 10 minutes on how to create that virtual interface, that msloopback. Once I have that msloopback interface, I would then go to GNS3 and add a cloud. So I'd grab the cloud object. I screen this over. Just grab the cloud, drag it out here, and then double click on the cloud. And when you go to properties of that cloud, I move it down a little bit now. When you go to the properties of that cloud, it's going to ask you what interface do you want to use. And I simply chose my Microsoft Loopback driver right there. So that was highlighted. I clicked on add and poof, that cloud is now logically associated with that Loopback interface. Once that's done, we can click on OK. I click on cancel because I had this pre-cooked already. So then we can connect that cloud, which represents our Loopback interface, to the switch. So from here to here is the cloud to here. And to do that, use this connection tool, and you can say manual, and then simply hover over this and click on the actual connection you want to make. And it'll show you that option. So if I click here, it shows me that NIO gen blah, 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 which represents my virtual loopback or my MS loopback interface. I click on that, I connect to the switch, and that's this physical connection right here. Next, I drag over my routers. So I drag over R1, I drag over R2, R3. You don't have to use switches in between them, but I do it because it makes captures and CPU utilization not as much, I found, on Windows 7. Which, by the way, is not my preferred platform for using GNS3, but I use it because I can integrate this logical PC here. So once I have all the connections built in place, and you can show those connections with that right there. I'll take that off a little bit crowded. But that's the physical connections that are represented here. The next thing I'd do is I'd go to the router itself, and I'd make sure it has the interfaces I want it to have. So you double click on it, and then go to R1 in this case, go to slots, and make sure it has the Ethernet adapters and serial interfaces that you want. Once it has that, I would then go to the console. You can right click and select console to open up the console of this device, or you could use a third-party tool like PuTTY or Secure CRT to logically connect to it. So here, if you notice the third line down, it has the console as port 2001. So you just aim your Secure CRT to your loopback IP address 127.0.0.1, and you say port 2001. I want to do telnet to that non-standard port, and that'll connect you to it. So when you have that in place, it will look something like this. So here's R1. Well, there's R1. Here we go. So we have the connection in place, and now we're logically sitting at R1. The other thing I'd strongly recommend is that you put in a baseline configuration. Here's the baseline I use. I take this line by line and I paste it in, copy paste. The really most important pieces are right here. The line console 0 and no exec time. Anytime you have a router waiting on a user for inputting something, the CPU on Windows goes way, way high. So I put this in on every single device, and then on every single device I would do a WR and save it. Once you've saved the config on all 4 devices, or in this case all 3 devices, you go back to GNS3 and click on the Save button. And that will save the configuration so that next time you bring this up, it will still be there for you. So a couple other things as far as testing goes. Once the PC has its IP address and the router has its IP address to verify connectivity, there's a lot of firewalls that are built into Windows. And unfortunately, if I try to ping from R1 to the PC, the firewall software on the PC would say, oh, I didn't initiate that request, I'm not responding, which is a great thing from a security perspective, but negative from a testing perspective. So on the PC, we might be able to ping down to the router because we're initiating that connection. So on the PC, we could go ahead and do a ping of 10.1.0.1, and that's the connection right here. So a little reminder of how all the pieces fall together, really important. Number 1, make sure when you bring up your routers, you right click and you run the idle PC option. I'll scroll up a little bit here so you can see it. Okay, so here's the idle PC option right here. And I would bring up one router, run the idle PC, get a good number has the asterisk next to it, select it, save the config, then go to R2 and just turn on one router at a time. So I'd turn on R1, bring it up, base config, save it, idle PC it. Go to R2, bring it up. So now R1 and R2 are up, and put in the baseline config, idle PC it, save it. Then go to your 3rd router, 4th router. Same process, one by one. And what we're trying to do is find that sweet spot where the idle PC is going to be working for your computer. Not one idle PC works across the board for all systems everywhere, and only 5 people know that secret. The idle PC is unique to your computer and with what's going on with your computer and your topology. So that's how you'd set it up. And what I'd like to do is invite you, if you are interested in IC&D, come check out our offering. It's going to be awesome. We've done Network Plus, Security Plus is in the works. IC&D 1 is going to use this topology as a foundation, not the only topology, but one of them. And we're also going to be doing IC&D 2 and, in fact, the entire CCNP track as well. So thanks for watching. In this lesson, what we've covered is we've integrated a logical Microsoft loopback into GNS3. We've identified how to connect it into GNS3 via the switch. We've also identified how to set the idle PC and how to bring up one router at a time, running the idle PC as we go to get the final perfect network. And then when we're done, we want to click right there and verify that GNS3 has saved all of our working configurations. Because in the bottom of GNS3, if we haven't saved them, they won't be there when we come back next time. Hey, everybody, thanks for paying a few minutes of attention. I appreciate it, and have a great, great rest of the day.